Hello, everyone. We're going to head and get started now. This is Alfredo Abate, your current Chicago Oracle Users Group President. Welcome to today's webinar. As an attendee, you'll be in listen-only mode, but you can ask questions in the chat window, which we will monitor. All questions will be answered at the end of the presentation. We'll also be streaming live on our YouTube channel, and the recording will be available there to view shortly after the presentation is finished. It's really great to be here with you today virtually. As most of you who are regular members know, we haven't met in person in a very long time. For those that are new to the Chicago Oracle Users Group, we welcome you. Traditionally, our group meets between 4 to 6 times per year in various locations around the Chicagoland suburbs for presentations, as well as hands-on workshops by Oracle experts, ACEs, and authors. Unfortunately, with the restrictions in place due to COVID, we didn't know if we'd be able to meet in person this year, so taking cues from some of the other user groups, we decided to go virtual. Today is our third webinar in a series of 20 that we'll be holding for the next 20 weeks. Our schedule is completed, and we've added all of our July and August registration links. So we'll continue to add more registration links for the remaining sessions, probably within the next week or two. So continue to keep an eye on our website so you can register for those sessions as well. If you're not aware, our website is just coug.us, and you can also see the URL there right in front of you on the slideshow. For those who are regular members, you probably are aware that our user group runs completely unfunded. Our members have never paid any dues. Our meetings have always been free. So I'd like to take a moment to thank our sponsor, OAppsNet Partners. They are an Oracle Gold partner and systems integrator with specialties in areas of financial business solutions based on Oracle applications, both on-premises and in the cloud. And they also provide services in the areas of AP automation, Apex development, database upgrades, and administration. Next week, don't miss our webinar with Oracle ace Sean Scott on getting started with Oracle and Docker. You can register for that one on our website right now. Today, we have the great pleasure of having Jeff Smith with us. Jeff is a product manager on the Oracle database team, specializing in database tools. He blogs at thatjeffsmith.com and tweets at @thatjeffsmith. Jeff, welcome. Thank you so much for joining us today, and I'm going to give you control of the screen.
Awesome.
Let me know if you're able to bring yours up.
I was going to turn my video on and say hi, but it's telling me it can't do that. So you don't need to see my face today. Thanks, Alfredo and Chicago Oracle Users Group for having me. I'm responsible for a few products at Oracle, what we call the database tools team. Most folks know us about SQL Developer, little tool maybe you've heard of before. About 7 million users worldwide. But for the last 5 years, I've also been helping out with Oracle REST data services. And for the duration of this talk, I'm just going to call it ORDS, because if you know anything about Oracle, we prefer acronyms for everything to make our users feel dumb. So we'll do that. That was a joke. You're allowed to laugh. I won't hear you because you're on mute, but you're allowed to laugh at my jokes. And also because I only have an hour. So if I said Oracle REST Data Services for every time I had to say the product name, you'd be here for a long time. Feel free to reach out to me. Email. Just don't forget my middle initial. There's more than one. Jeff Smith at Oracle. And Alfredo kindly plugged my blog. Thanks, Alfredo. There is on my blog a resource page for ORDS, where I try to break down all the things that you're going to need to know to get started and start building things and general introductions to other features. I even have links to slides and videos. So feel free to kind of sit back and kind of just enjoy the ride today. Don't feel like you have to take copious notes. I don't know if I have this exact slide deck publicly, but if I don't, I will update that and send a link to Alfredo so he can include it on the next newsletter, or just feel free to email me and I'll be happy to send it to you as well. So I'd do this talk anywhere between 30 and 60 minutes. And I thought today I'd aim for 45 minutes. I think we have, what, about 30 people on the call. So if you want to ask a question, I think you're going to stay muted. But feel free to send questions on the chat. Is that okay, Alfredo? I'll keep the chat panel open. So if you want to ask a question, that's probably a good way to do it. And at the end, I'll stay on for as long as people want to hang out, and we can ask questions there as well, or have discussions. So for this hour, I want to talk about just what REST is, and a little bit about why an Oracle database person should even care about it. And then I want to jump into some practical, well, here's how you go about building web services or RESTful services that interacts with your Oracle database. REST is another acronym. We've heard the term lots and lots of times, and a lot of people equate HTTP with REST. REST is almost always accomplished by providing an HTTP interface to something, but REST is more of an architectural style. It's not an actual API or language. And these 4 bullet points basically describe what an architectural implementation follows the REST paradigm would look like. So you have server where resources lie, and generally where all of the application logic lies. And then you have clients that make requests to that server. And on every request they make contains everything you need to know to make that request happen. So everything is stateless. Nothing carries between requests. So it's not like an Oracle classic environment where there's a SQLnet connection that lasts for seconds, minutes, or even hours or days, and where you can take things across requests and have things like commits and rollbacks. In a REST or HTTP world, we kind of live in an auto commit land, which sounds kind of scary, especially if you're a DBA. But it just means you have to build your applications quite a bit differently. So caching is not really a thing in ORDS, but to make REST possible, it generally allows for caching all along the wire, from like where your application is sitting and where your server is sitting. And that's definitely true with the internet. You've got caches in your browser, you've got caches in the mid tiers where all the web servers are sitting. And we do offer a little bit of feature there in ORDS, but it's not really the focus of today's talk. And maybe one of the most important things is this uniform interface. So when dealing with an API, it can be a brand new REST API for you, but there's certain rules of the road that you're going to expect, and it will just be there. The verbs that you'll be using are all going to be the same. Responses and requests are all going to have very similar looks and feels. The responses are going to follow a certain set of rules, and it makes it very easy for a developer to work with just about any sort of resource out there. At the end of the day, they might not even care that there's an Oracle database. But as a DBA or developer, if you provide a RESTful interface to your database, any developer that's used to working with HTTP and the REST paradigm is going to immediately be able to start taking advantage of it. They're not going to have to learn anything new. They don't have to learn about SQLnet or the old school OCI network rules. They understand get and put and post, and they're used to working with JSON documents, and they don't have to care about ref cursors anymore. They can just start taking immediate advantage of all of the value that the Oracle database provides, which is access to your to your data. REST APIs, there's really only two things you have to know. One is where is the resource that we're going to be making the requests to, and then you're going to actually make the request itself, which actions or verbs basically. So all the different things you can do with REST APIs, it's generally all things you can do with any API, but where we see the most being taken advantage of for our customers are people are building very nice web applications or even mobile apps. Instead of having a stateful JDBC or SQLnet connection to it, it's powered by HTTP. So it's very popular with people working with JavaScript, but really it's available in any programming language. So I think even if you really want to, you can find a way to make it work with COBOL HTTP. And that's probably why the adoption rate has been so heavy, is that's because of just how ubiquitous HTTP itself is. And when I say HTTP, what I really mean is HTTPS, and especially for an Oracle database, you want to encrypt everything always, especially if you're going over an open network. It's also quite popular for CI and CD pipelines. And we have database management REST APIs available as part of ORDS. You can create pluggable databases, you can launch data pump jobs, you can execute ad hoc SQL scripts, you can kick off stored procedures, you can schedule scheduler jobs. Without writing any of the 10,000 lines of PL SQL to interact with those interfaces, you can just simply do a get, a post, or a put to ORDS, and we kick those things off for you in the database. Automation as well, so similar kind of frame there, but anywhere you've got access to command line, for example, you can do that stuff ad hoc or set up scripts to do that on an automated fashion. If you're in the Oracle Cloud itself, anytime you see something on a portal page that we have, the nice looking website pages, cloudoracle.com, all of the buttons that you click there, they all have corresponding REST APIs behind that. So you never have to use a web page dealing with an OCI subscription. You could kick off databases being created and backups and dropping tables and whatever you want to do completely via HTTP calls. And those REST APIs are documented, and they're, you know, click over to the documentation link and feed them into your REST client. And, you know, they're all immediately available as soon as you have your credentials configured. So as I said, a lot of people equate HTTP as being synonymous with REST. And I thought I would just show an example of what bad REST would look like. So you generally have a resource, which is going to be like a noun. It's a thing. And then we're going to have actions that we are performing against these resources, or a verb. And you always want to see in your REST APIs, when you have your templates, which make up the description or the location of your objects, you always want to see them take kind of that noun form. You never want to actually see a verb in the resource address. So the one that's red up there, delete imp, that's a bad RESTful thing. Because if you're doing like a get, which should be a read-only type operation against an object called delete imp, you're going to have to trust the API docs that say, hey, this gets you a list of employees that have been deleted versus it actually going and deleting employees. So what you'd want to always have is have a resource called employees, and then have appropriate verbs to do what you want. You know, getting a report, or adding or changing an employee, or maybe sadly deleting employees. And if you actually wanted a list of deleted employees, then you could have a query parameter added to that first one there. So I could say get HR employees / something something equals deleted. The HTTP protocol has, I think, 7 or 8 verbs defined. For ORDS, for making things in the database accessible, we've done all of them with these 4 verbs: get, post, put, delete. So with those, I can run SQL statements, I can execute anonymous blocks, which basically means I can do anything in the Oracle database that I can do with SQL and PL/SQL, which really at the end of the day means I can do anything in an Oracle database, because SQL and PL/SQL are the ways of doing everything in an Oracle database. The other nice thing you want to do to respect the consumers of your REST APIs is you want to provide them a way to go from point A to point B. And the way that that's done is with hyperlinks. So when I add an employee, maybe if I do a put on the employee's resource, yes, I should get a message back saying, oh, hey, we added Alfredo to the employee database. And that's good to know. But what would be even more helpful is if in that response, there was also a link that I could click on or follow to actually go see Alfredo's employee record. So when you're building your REST services anywhere, not just with ORDS and Oracle database, you want to have in mind what the path is going to be. You know, when someone's following your API, how do they walk that path, and what are you doing in your responses to help them get there? Show where they came from, give them a link to describe where they're at the moment, and if possible, give them a next step link. And ORDS has a lot of that built in, and you can just take advantage of that without having to write a lot of extra code. So the way we make all of this available is with a product that's included for free with your Oracle database. And when I say for free, I mean you're paying for this via your Oracle database license. So it's a no additional cost feature of the Oracle database. And if you're using a free version of the database, it's still included. And the product name is Oracle REST Data Services, which we call ORDS. So it's a Java application that would generally run in the mid-tier, but you can run it anywhere. You have a Java runtime engine available, and anywhere that's going to have access to your database. So ORDS itself is going to have stateful permanent connections to the database, but it's going to be accepting all of the web requests in that kind of middle piece of the architecture. And then it's going to pipe your requests over to the database and get the answers back and then tell you what you need to know. So you don't have to worry about database users and IP addresses and TNS service names and all of that. You just need to know information about the web server and the REST APIs. We handle this for any version of the supported Oracle database. So 11G R2 and up, and please have plans to get off 11G R2, because final support for that is going to be going away. And the best place for you to go from 11G R2 is 19C, because that's our long-term support platform for the 12C kind of product family. But I'm not here to talk about that. But you can have as many Oracle databases as you want from 11G R2 all the way up to 20C, supported and maintained by a single instance of ORDS running if you want. Or you could have one container database with 15 pluggable databases inside of it and have one ORDS service all of those if you want. Or if you need to, you can stand up one ORDS for every database that you're going to deal with. It's completely up to you. When you're getting started, you can use our automatic feature where you actually just point to database objects and say, hey, ORDS, please publish a REST API for this thing in the database. And you don't write any code. You just then exercise the APIs that we maintain for you. Although if you're a developer, you're probably also kind of a control freak, and you probably have users that have very specific requests for how things should exactly look and work and feel. So in which case you need to build your own REST services. So we support both of those. We also automatically handle things like, hey, you just asked for, again, that list of employees. And here at Oracle, we have like 136,000 employees. And if I'm on my mobile app running your stuff and I ask for a list of employees, it's not going to send back 136,000 employees. It's going to send like the first page. And you're probably going to print that on a screen with like a search and an order and a filtering mechanism. And at the bottom of that page, there's probably going to be a link there that says, go get page 2. You don't have to write any of the code to know how to go get just the first page and how to jump between different pages. You just write the SQL that represents that collection of things, which in this case is rows in a table, and we handle that paging for you automatically. With the popularity of JavaScript exploding over the last 5, 6, 7 years, so has the JSON data format. And it's really overtaken and probably almost killed by itself XML and sort of the SOAP paradigm. But for your REST services, we automatically take responses, whether you've executed a stored procedure and it just comes back and says, okay, executed, or it's got a ref cursor, or it's got 3 out parameters, or it's a simple SQL statement with the result set, or even if you're using a cursor and you've got nested rows inside your SQL statements, ORDS automatically takes all of that output and converts it to JSON for you. So you don't have to write any of that code either. You can do, like I said, anything in the database that your user can do, where those REST services are defined, anything you can do with SQL and PL SQL. So it's really up to your skill set and imagination on what you can accomplish with these REST APIs. We give you a GUI, which is SQL Developer for building and maintaining your REST services. Although if you're also an Apex user, they have some nice screens in your browser you can use. We also give you the command line interface, which would be SQL.cl, and we also give you a PL SQL API. So you can basically manage and build and deploy these REST services with anything that can execute code on an Oracle database. I can't believe I've gone so long already without saying the cloud word, because I don't get paid until I talk about cloud. But our technology, we don't care where you're running it. We prefer you run it on our cloud, but you can set up this entire stack in your own on-premise data center. You can run it on your laptop. You can run it in a Docker container. And there are various Oracle Cloud environments where ORDS is stood up out of the box. Like, so for any autonomous database, ORDS is already up and going for you. Okay, so let's look at an actual example of a REST service that is going to help you work with something in the database. So like I said, every REST request requires two things. Sort of the address of the thing, and then the verb or the action you want to perform on said thing. So here is the thing I want to work with, and my action or request is this get. So it's probably a report, basically. It's saying we can look at the URL and guess what it is. We're looking for what looks to be like a list of employees where the department ID is set to 50. This is a kind of a query parameter. And if I look at the output from ORDS, here's that JSON collection. So I've got an array of employees here. And with each employee, I'm also given a link. So if I wanted to paint a screen and show first name, last name, employee ID, and then let someone click on the name to go find the employee record, I would just need my web app to be able to follow these related links. And ORDS is handling that for me. I've got several hundred employees in Department 50. So at the end of the JSON response, there's an attribute called has more, which is basically telling you, hey, guess what? There's more records to go get. We've only grabbed the first 25. And if you want to go get the next page, well, there's a next link down here that you can follow to go get records 26 through 50. So that's a little bit of the value of ORDS here. Behind this REST service, I've either got something like a table that's been auto-enabled and there's no code behind it, or maybe I've got my own service that I've written that's backed by something like a SQL statement that's a select star from, or I could even have a PL SQL program or API backing this get handler. So I could do a get on something, have PL SQL run, and what it returns is a ref cursor, which is then also presented this way. So you got lots of different options for making this stuff happen in the database. But at the end of the day, all the stuff that you're making happen in the database is all the stuff that you're already doing with SQL and PL SQL, which I think is what I was just trying to say with this slide. So if you're ready to start building stuff, let's look at your options. So if you think of us being like in a REST restaurant, and we're looking at our REST menu, what I see a lot of people starting are the automatic features. So it's nice for a hello world, be up and running, proof of concept, install ORDS, get it configured on a database, REST enable a table, and then give someone some links to play with. It can be that simple. You can install ORDS in about 5 minutes. You can REST enable a schema and a table in about 5 seconds. And you can start running reports on rows in the table. You can start changing rows in the table, deleting rows in the table. You can even batch load via CSV with the auto feature. Same thing on views. By default, it's generally just going to be a get handler, but if your view has a primary key definition on it, then it adds the full CRUD stuff too. And not really a REST paradigm sort of thing, but for a PL SQL object, we have an automatic feature there too. It's sort of more remote procedure execution, but we give you an HTTP post method for accessing your PL SQL programs. So most shops have sometimes a 30-year catalog of PL SQL APIs that they've built. And if you need to start making RESTful web services available, it could be as simple as installing ORDS and just taking advantage of those existing PL SQL APIs. And so your REST services just look like anonymous block wrappers that call those existing APIs. It doesn't have to be a lot of work. But you can also say, I want to auto enable a PL SQL program. So we say, okay, for this package, this is your URL. And if you want to execute a procedure in this package, just do a post on package / procedure name / and on the body of that request, give us a JSON document with the input parameters, and we handle that for you and give you the results back. So it's quite powerful. Most customers, end of the day, eventually end up writing all of their own REST services, but for many use cases, the auto stuff is more than enough for what you need. Like I said, most people end up writing their own services because that's because you get full control. You decide, hey, I don't want every single column in this table or query to come back. I only want these 2 things to come back. That's up to you. You don't have to stay with the SQL that we generate for you on the auto stuff. It's your SQL that's going to run. If you want to be nice and provide links, that's up to you. If you don't want to be nice, if you want to be very terse in your responses, you get to shape the responses. You also get to handle the error codes. So when someone makes a mistake and they exercise your API correctly, you can be nice and you can trap things with exception handling blocks in your PL SQL, and you can return very nice messages on the web responses. Or you don't have to, or you don't. It's totally up to you. And then at the end, if you're not too full, we've got several other features. We've got REST-enabled SQL. So we have an endpoint that can be used to ad hoc execute SQL statements or PL SQL scripts or SQL plus cell scripts. We have a management API for the database itself. So show me a list of users in the database. Show me a list of invalid PL SQL in the database. Show me the most expensive SQL in the database. Execute data pump for me, all via HTTP. So that's quite powerful. And then we have SQL Developer Web, which is a web app powered by ORDS. So REST APIs powering a web application, in which case ORDS is handling both parts of that. And you've got SQL Developer running in your browser. So you can have a SQL worksheet and browse the contents of your schema, and run SQL statements and get performance pages and all kinds of good stuff. None of those features are on by default. So if you install ORDS, you have to explicitly turn those on. So if any of that freaks you out on the security side, good. That means you're thinking about security, which is good. But that stuff doesn't just accidentally end up in someone's browser. So with ORDS running in the mid-tier and you doing something on your browser or mobile device or curl, bash script or computer, when you make that request, it goes up to ORDS. ORDS figures out which database you're trying to talk to. Because again, you could have 50 databases being serviced. And that address that's passed basically has a mapping pattern in it that ORDS recognizes and goes, oh, they want to go to this database. And the end of that resource is going to be tied to SQL or PL SQL or both. And ORDS is going to run that. It's going to get all of the results back. It's going to format it to JSON. And it's going to give you the response back. And every request you make ends up with a new session in the database. It does the workload. It then closes the session and gives control back. So when you're paging through the contents of a table, like I was showing before, every time you go to click for the next page, it's walking this complete path again. So we're not leaving a session open on the server to jump back into to go do an additional fetch. It's saying, okay, connect as this user, run the query, jump to this set of the results. So again, that's another example of what we mean by stateless. HTTP is all about requests and responses. So here's what requests can look like. Gets are usually the most simple. You don't have a body on a GET request, but you can have headers. And you can also put things on the URL itself. Again, the most important things are the address and the method. The responses, there's always going to be a status code. So 200s and 201s, that's what you get back if what you just did worked. 201s, what you get back if something was created based on your request. And then you can have headers on the request response. And there's also generally a body. And the body is just the payload. It's like what would eventually be used to paint your screen. So in this case, it could be the JSON document, or it could be anything. It could be an image file, it could be a PDF, it could be XML, it could be CSV, it could be whatever. It's basically whatever we've got programmed to come back in the request. And if we look at this in curl, it's kind of a pain in the butt to type. That's why that's why HTTP clients are pretty popular for testing. I've talked about data pump a little bit. So this is what a request to data pump 2 tables and a schema using 2 threads and to write to a specific directory looks like. Alfredo could tell you how many lines of PL SQL that would take. By the way, that same PL SQL is still being generated and run, but ORDS is doing it for you based on the attributes that you included on the body of this post request to the database API, to the resource that we've called data pump export. And here's a response coming back from that same request. So lots of things are being generated and happening when you do a data pump request. So what ultimately happens is we're creating a job for you. And in the response, I'm saying, okay, 201, because we created that job. And I'm giving you a link that you can go follow to see what's happening with your job. Actually, I'm giving you a couple of links. Excuse me, giving you a link to the job, a link to the log for the job, and then something else I forget. If we look at these request uniform resource, we usually say URL, but fancy people say URI, same difference basically. They're composed of a couple different pieces. You'll generally always see ORDS as the first piece, the base part of the URL. And that's because as a Java servlet, we're running this thing called ords.war, and that's just adopted as the base mapping point. If you rename this to apex.war, it shows up as /apex. If I renamed it to Jeff, it'd be /Jeff. Now, what comes after that can depend on your setup. So if I have ORDS servicing 50 databases, the next thing I see won't be a schema, but a database name. And really, I shouldn't ever see a schema or a database name. What you'll generally see here is an alias, but I just have the actual schema name here, so it's clear to you what we're looking at. But my REST API lives inside the database, inside the schema. So when I'm executing things at this point, they're being ultimately run in the database as user HR, which gives us a couple of nice things. One, we're limited to what the HR user can do. So we automatically inherit all of the security built into that account. And we can also be limited by what resource consumer groups have been put into place for this schema. Which means you probably don't want to publish your REST APIs in the same schema that your data lives in. You probably want to have it in a separate schema. So you want to follow that classic 2 or even 3-tier schema layout for your apps. One schema for data, one schema for PL SQL, and a third schema for users. In this case, your REST APIs would either go in the code schema or the user schema. I would say maybe the user schema, but you can put it wherever you want as long as you realize where you put it determines the user in the database that's being tasked to run the code. Once we get past the user, then we have a module and a template. So you think of a module as kind of like a package. It's a collection of things, and these things are modeled via these templates. And then once the template's been defined, we can then start to say, okay, I want to code verbs for this template. So you could have one or more or all of these, but without a handler defined, there's no code assigned to the template. And there's nothing really there to run. You don't just start putting stuff in HR. You have to tell ORDS that the HR user is allowed to be addressed and is allowed to store REST services. So we have this ORDS package. And one of the things you can do is say enable schema. And then when I said it's best to alias things like users in your database, you can do this via the mapping pattern. So you're basically on your requests, you're going to see the word auto demo in the URLs. You're not going to see ords_demo. So what this is doing is you're not advertising to whoever has access to your REST API that there's actually a user in the database called ords demo. So you're kind of taking away an attack vector there, so to speak. You don't have to do that. You're more than welcome to leave the mapping pattern to be equal to the actual schema name if you want. So after we've REST enabled a schema, then we have to start building REST services. So this is a screenshot of SQL Developer. And if you're on a modern version of SQL Developer, when you're browsing your schema, you can right click on the table and you can say REST enable, or you can go to the REST data services section and create modules and templates and handlers. everything's in the Oracle database, everything's in the ORDS schema, so you can query that just like you would anything else and get back a report of what you've got turned on in ORDS. So here I have a list of verbs and addresses and like the first 50 characters of the code behind those. My examples usually aren't very good other than to demonstrate how to do something. If you're going to copy and paste my code, do that as just as a getting started. And hopefully it doesn't end up in production without a lot of testing from your point. If you are using SQL Developer, then when I go to start coding these, then you get the same worksheet that you're used to seeing and the insight help, and you can actually test your REST services there in your desktop. Now, as soon as I click save, it gets published into the database, and ORDS is going to see that and be immediately available to run it, assuming that the REST service is enabled. If you want to, you can even use SQL Developer to install ORDS and configure it. But to be honest, I would say it's probably worth the time just to get used to using the ORDS Java command line interface. It's a couple of simple commands. You can run ORDS from the command line. You just say java jar ords.war and then follow that by the command. If you said instead install, it would send you through like a 20-step yes or no simple config list of questions, and when it's done, it starts up and is running. So that's running ORDS as a standalone program. You can also dump ORDS into as a Java servlet into something like Tomcat or WebLogic if you want. And then, like I said, we also have the PL SQL API. Now, if you're an Apex user, there's a set of REST screens there. And what we're working on right now is building equivalent, but even better set of web screens for managing REST services into SQL Developer Web. So that's scheduled for this fall. Looking forward to that. So with the automatic thing, the number one advantage is you don't write any code and we're responsible for it. So you might also see that as a disadvantage if you want control over exactly on how it works. But we do take care to optimize these APIs. So if I REST enable a table, doing inserts, updates, deletes, and queries on that should be fast, assuming your statistics are up to date and your database is well maintained. We do give you a lot of features, so you don't have to code how to do a CSV upload. You don't have to code how to do insert updates or deletes or queries. And queries with filtering and queries as of SCN or timestamps, so flashback kind of queries. When you build your own REST services, you're in charge. So you get to code how the inputs are structured, what the outputs look like, how you do error handling. Please do error handling. But then again, you're able to do whatever you would do in SQL and PL SQL. You can export these as scripts, which can then be source controlled. Please, please, please source control your REST services just like you would your stored procedures. And it's transparent because you know exactly what's happening because you're the one that coded it. I think I've said this a few times. So the automatic, you get quite a few stuff out of the box. So for a table, you've got the entirety of the table or the collection, which is referenced as employees / If I did a get on employee /, I'm going to get all the employees back. But you've got another template there, employees / ID. And if you think about it for about half a second, you can go, oh, I bet that's the primary key. Yes. So if I said get me employees /103, I'm going to get everything there is to know about Alexander Hummel. If I did a delete on /org /HR /employees /106, then assuming that Valley doesn't have any employees reporting to them, employee 106 just got removed. REST enabling a table is very similar to REST enabling a schema. And again, I do recommend you alias that, so you're not exposing actual object names in the database either. So here's an example of a get on a REST enabled table. And this query, kind of by example stuff in the URL, query parameters, that's all handled by us too. So we know how to take apart this JSON document and turn it into a where and or where order by clause. We also generate on these objects and your REST services an open API, what they used to call Swagger docs. So, building these REST services is one thing, but you have to be able to document them too, or no one's going to be able to use them. That's part of it. An example of querying. Update, very similar to an insert. You're going to include on the body of your request what you want to change or add. And the response, if it's nice, is going to be, okay, we changed it, or okay, we added it, and here's a link to go follow to go see that new thing. On the auto side, we're handling that for you. The PL SQL enablement, if I've got a procedure that has a return of an integer and a ref cursor, we grab those things for you, translate it to JSON, and report that back. And you don't have to worry about figuring out how you get a sysref cursor as JSON on the way out. We also automatically figure out how to go from a JSON document on the request body to put those in as arguments to the program itself. So this is a horribly named parameter, but my PL SQL program has an argument called string. So on my post request, JSON document is string. Good morning, Montreal. I did this talk in Montreal once, go figure. That's what's passed to this program when it runs. All right, REST services. So you writing the code, you're going to define the template. And this is where I suggest everyone start. Kind of sit down and brainstorm what that path is going to be through your workflows. And every time you get to a new place, you need a template that represents that place. And once you're at that place, you need to figure out, okay, what's going to happen at that place? What verbs am I going to make available? And once you have that pretty straight in your head, then you can start coding. I think it's almost like data modeling. You kind of want to have this map thought out before you just start into it, or you're going to figure out, you skip the step and it's going to be messy to go fix your patterns. And once you have the handlers defined, then you can start writing code to back those handlers. So for every request also, you're going to have to figure out like what's going to be required to make this request go. So parameters are just basically your inputs and your outputs. What are you expecting on the request and what are you expecting to go out on the response? So in SQL Dev, when you're doing this kind of stuff, I've got my module, my template, my verbs, and then on this post verb, for my media resource in my Aura magazine module, I've got XORD status code, which is going to go on the response header, and so is location. And then I've got this thing called file name and file type, I think, which are on the headers of the request. And I'm going to say, okay, for this to happen, we're going to have PL SQL backing it. Here are those parameters. So these parameter names are how they look on the HTTP responses and requests. The bind parameter is how those items are addressed in your SQL or PL SQL blocks. So if Alfredo's taking this program from me and needs to make a change to it, and I've done something dumb like return to 200 when this is actually uploading or adding a file and he needs to fix it, he needs to find something in my code that looks like colon status equals 200 and change that to colon status equals 201. So that does that work in the database block. But when it's returned in the HTTP response, the name of the variable is this and not this. And then you've got, is this coming in? Is it coming out? And then is this actually part of the response, or is it on the header? And then also, is it a string or is it a number? And this is how simple the code can look. This is how simple inserting a file to a blob can look. So I'm pulling off the request, the name of the file, the type of file, and the file itself, and I'm just inserting it into the table. This colon body is a special bind variable that ORDS gives you that says take the contents of the request body and load that in as a blob. So if my media table has a column of type blob, it's very simple to insert the body of your request as a blob to this table. And here I'm assuming it always works, so this is bad code. I'm just assuming that insert always works. And I'm saying, hey, your status is 201. And here I am setting the link. So I have to give you a link if I want you to follow it. And I do this with the location parameter. And I'm forming the URL pattern to click on to go get that thing. So I'm saying returning ID into image ID. So this is the primary key location of the new entry. And I'm saying, okay, where we're at now, slash, 567. That's where you need to go click to go get this thing later. REST clients, they make it real easy to like just point to a file and say, make that the body. So it could be as simple as click, 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 go to, uploading files to your database. If you decide to store files in blobs, that is. And we support globs as well. And here's the response to that request I just made. I was nice. I gave you a 201 and I gave you a link to go click. I didn't have to do this and I didn't have to do this. That file would still go up, but it would be real hard for you to figure out what the hell was going on. That's because I wrote this code. If I was being really, really good, I would have exception handlers to check things like, oh, valid file names, or that you didn't upload an empty blob, or you had permissions to the, I just want to check the normal ORA and PLS type errors that might occur in doing something like an insert, trapping those and giving you nice polite error messages back. So again, templates. For me, if I'm going to start building REST services, I always start by brainstorming what the templates are going to look like, and then kind of attaching verbs to those templates. Like, hey, I need to be able to address the collection and then the item in the collection, and I'm going to do verbs against those things. The responses are generally going to be JSON, but they don't have to be. You can write your own responses and format them with MIME types. And your browser knows exactly what to do with CSV once you tell it it's CSV, but you're responsible for writing the code that tells it's CSV. Will automatically do the JSON bit for you. And you can also tell us, hey, this is just a single thing. No worry to do anything with the paging because there's only the one thing. Or you can say, hey, this is going to be a list of things and I need you to account for the paging. And then you have a little bit of control over the types of links that you want included. I've gone way too slow on this. But I have a REST service defined in here where I have said that my source type is a media resource. And in my response, I'm passing back a file in a MIME type of image. And my browser goes, oh, here's this binary stream. It's telling me it's an image. Let's render that as an image. But this could have been a JPEG. It could have been an MP4. It could have been a PDF. It could have been an Excel file. It could be whatever. So it's not always just rows, and it's not always just JSON. Your REST services can also just print out HTML. So you can have the database with the HTTP package just print HTML back on the response versus doing JSON. Doesn't have to be JSON. So if you go to my blog and go to the ORDS resource, I've got one of the articles there is kind of an image gallery example where you can browse the contents of the image gallery, and you can upload files and then also download files. And it's a good example because it gives you an overview of how the templates work and how the verbs work, and how to use the parameters for like HTTP responses, and then also how to get JSON back and also get media resources back, and also how to pass things like links and other things. So it's kind of a good primer for all of the basics. When you're done coding, set your code out to be stored in a file somewhere and commit that to your source code repository. Please don't treat your database as source control. Here's what the Swagger automated documentation looks like. In terms of versioning, our liquid-based support in SQL CL also supports Apex apps and also supports ORDS REST modules. So you can say, go generate a change log for me of my REST services and go update that as new versions come out, and you automatically handle the dependencies and history tracking for you. It's also nice for CI/CD pipelines. And I'm out of time to do the bonus round database API stuff. But if you are interested in managing your database via REST, when you install ORDS, you enable it. And then if you pull up the endpoint for the database API and get this link, you can then take your favorite REST client and do an import. And then you've got access to like these 300 plus DB API calls. Most of them are GETs. There are a couple of more interesting verbs in there like data pump and DBCA. But here's an example of get a list of database components, and I make this request and I get it back here. So Alfredo, can I have an extra 5 minutes to go over the questions?
Absolutely, because we've got a couple in there. So
I saw. Okay, Jeff, you are so awesome. No, no one said that. I always pretend someone did. Are there advantages to doing something one way over another, similar to connection pooling? This is in regards to one ORDS for all. Yes. So I didn't really show an architectural diagram for ORDS, but you could have ORDS running on the same machine as the database. You could have it running in an actual mid-tier with your web server. But you could have 15 databases with one ORDS, or you could have one ORDS for each database. And so the beauty of one over the other is just the configuration flexibility that you have. So one ORDS for 15 databases. If that ORDS goes down and you don't have failover set up, you've just lost your web server for 15 database applications. that would be a bad setup, and you would want to have multiple ORDS going with failover setup, which you can do. But having one ORDS for 15 databases means you have one set of config files, and it's easier to do an upgrade too. So you upgrade the one ORDS and you're taken care of. Having 6 ORDS for groups of 6 different databases, you might need different sets of configurations. You might need some features turned off in some places and not in others. You might want different versions of ORDS for some reason, so it's kind of more of a practical decision on your part. There's not really any tech. I will say for doing multi-tenant, you can do an ORDS install in the container for all of your PDBs, or you can have it installed at the PDB level. Maximum flexibility is to do it at the PDB level, and then you can have each PDB running its own version of ORDS, whereas if you do it in the container, they all have to be the same, although that does make upgrades easier. But I have seen customers have less of a hassle if they do it at the PDB level. Someone's asking about, or the same person's asking about best practices regarding JSON, CLOB, and blobs. So blobs, if you need to serve up some sort of file, that's generally the way to go. For JSON itself, the JSON team actually recommends you store JSON in the database as a blob. But in terms of working with JSON and ORDS, you've got access to all of the JSON APIs in the database. ORDS itself figures out the JSON translation for you. Betty, if you want to ping me after this with more details on your question, I can probably give you a better answer. Someone's asking about connection pooling. So yes, as a Java application, we're using JDBC connection pools for your databases. So each database will have at least one connection pool, and that connection pool, by default, out of the box, has 10 connections going. Sizing the connection pools is probably one of the most important things you can do to maintain performance. I can't tell you what the magic number is for your app. It basically comes down to how busy is your ecosystem and how fast is your SQL and PL SQL. The slower your code is, probably the more connections you're going to need available in your pool. Because if your stuff's really, really fast, things aren't going to queue up too bad. But if your requests aren't taking a second or less, because what happens when you try to load a web page and it doesn't come back within 2 seconds, you hit refresh, right? So just imagine people, they're hitting the refresh button, bing, 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 bing. As those requests start to stack up because they're taking too long to run, you're consuming more and more connections out of the connection pool. So in a web world, in a stateless world, aim for PL SQL blocks and SQL blocks that run in milliseconds, not seconds. How do we protect our services? Yeah, so I didn't talk about security, which I always have to pick one thing to skim over because there's not enough time. So there's a couple of different ways to secure a service, but they're generally done around these things that we call privileges, which is an overloaded term. This is not a database privilege. This is an HTTP privilege that is assigned to the authenticated HTTP user via a role. So I've got a privilege called blog RSS that I've used to protect a module called blog. So any template under a blog, if someone tries to access it and they don't have this privilege, they're going to get rejected. Now, how do we deal with authenticated users, or how do we authenticate users? Ideally, that's happening outside of ORDS. So if you drop ORDS into Tomcat or WebLogic, you've already got authenticated users there. And then you just give those users the roles that they need to access your things. If you need to run ORDS as a standalone web server because you don't have Tomcat and you don't have WebLogic, we give you an OAuth 2 client and workflow that you can use where you have access tokens and users authenticated that way, and they have the roles granted to them that way. And I won't say worst case scenario, but if you absolutely have to have it, you can also use database authentication to access your REST endpoints, which means you're giving a consumer of your REST API credentials to a user in the database. So we generally don't like to do that, but if you're okay with it, we do support that. How does ORDS work with virtual private databases where the object is controlled via DBMS RLS? It works very well with it. So David, if your authenticated user, if your REST service is published in a schema where VPD is enabled, their view of that data is going to be tied that way. Now, if you're asking about each authenticated user coming in needing a different VPD, then we do have this thing in ORDS called a pre-hook procedure, where once you're authenticated, we let you inject some SQL or PL SQL that basically warms up or tunes the session for what's going to happen next. So I think in the pre-hook, you could run some code that would basically put that session into the virtual private database you want them to have. Oh, look, someone actually did say I was awesome. Thank you. That was nice of you. What is the app on the screen? Okay, so this one right here is the REST GUI that I like to use. This has nothing to do with ORDS. You can use this to make REST calls on anything. It's free. It'll run on your Mac or Windows or Linux, so it's nice that way. But probably the most well-known REST client is Postman. You've probably heard of Postman before. I just like to use something different because I like to be special. But they all basically have the same kind of idea. You define the thing that you're going to do the operation on. You assign a verb. You define your request body, your authentication. You do the thing. It does the call for you, and then it gives you a nice view of what came back. Both a formatted pretty view if you want. You can see all the headers, which are nice. So you kind of get the equivalent of what Chrome DevTools would show you up here. But for gets, this is interesting. Where it's really interesting is for posts, puts, and deletes, because you can't do that in a browser, or at least not very easily in a browser. So for me to go create a data pump job, here, an import job, that Swagger JSON document that I imported here, it formats the body for me. So I need to provide values for all of these to be able to perform the data pump task. And then when I'm ready to go, I just click send, and it makes that call for me. So I don't have to use curl, but you can also say copy as curl. And then if you need to put it in your bash script, it's a little bit easier. That's Insomnia, but most people use Postman. There's like 100 REST clients out there. Being new to this, what is your recommendation on how to start architecting an ORDS implementation? Oh gosh. Well, I would say if you're new to it, I would just start playing with it first. So just getting comfortable with the different pieces. So you could put, if you're a Docker person, you could have a database and ORDS running on a Docker on your laptop and having a go at it that way. You could also, what I do, I actually just have ORDS running on my laptop as the Java app, and I point it to a database that's also on my laptop, and I have a go at it that way. In terms of architecting and implementation, I think you always want to start with security. How are the users going to be authenticated? And if you want to tie into like an existing database of users, like in your Active Directory setup, then you need to figure out how to get something like Tomcat or WebLogic talking to Active Directory, because that's always the hardest part. After that, you need to think about high availability and scaling. So what happens when a middle tier goes down, or what happens when a database node goes down? So you need to set up your connection pools that they speak connection manager, CMan, because CMan can tell you, oh, hey, this instance went down. We have an active data guard failover switch happen, and we're going to redirect all of the traffic over to this new instance. ORDS can just automatically respond to that. So you want to plan for that. And you also want to plan for possibility that an ORDS instance is going to go down. So you probably don't want to have one ORDS running. You probably want to have two, although we say three, because if one goes down, you still have two left. And it's a pretty small footprint, so it doesn't cost a lot to run multiple ORDS. The real cost of multiple ORDS is you're going to have multiple copies of these config files that you have to manage. And then after that, architecting, just get your code fast, get your SQL fast, get your PL SQL fast, and then make sure that the APIs that you're building are nice so that a consumer to them enjoys working with them and they're not always frustrated because they can't find links or the message codes aren't right or the error messages you're giving them are worthless. From a DBA perspective, what would be the benefits of using ORDS over OEM to manage and monitor databases? That's a good question. So OEM, you're going to set up OEM, and you know what that takes. And you're going to set up your agents or whatever they're using today for, if you're doing fleet management, you've got 1,000 instances and you've already got OEM up and running for those. I would say the benefit of using ORDS in addition to OEM is then you can do things easier inside those databases in addition to just managing and monitoring, So if you wanted to create ad hoc reports or changing the data in those databases, it's nice. The thing with ORDS is it's set up to do one thing, and that's be an HTTP gateway to the database. So if you wanted to create a monitoring type interface for ORDS, you could do that. I mean, it's sort of, there's a little bit of overlap there. So if you're a huge fan on OEM, continue to use it. ORDS is built by the database team for the database. And we support 11G up to 20C, and it's all free and included. So I'm also the product manager for ORDS, so I'm always going to tell you that ORDS is better. I'm probably not the best person to answer that question. I would say ORDS gives you a lot of flexibility to, bringing a little bit of SQL and PL SQL and committing that and having it immediately available. That's nice. Okay, so I think that's all the questions. That was a lot of questions for like 30 people. And thanks for sticking with me throughout the session. If you want to go to my blog, I do have some articles here on the architecture and like how some of this stuff works. And really maybe something to think about is even if you're not going to be using ORDS for anything that we've talked about today, you might want to just use it for SQL Developer Web. You could have a class of users that needs to be able to go and run reports or SQL statements against your data, but you don't want to give them access to the database itself. You don't want them using Toad or SQL Plus or whatever to connect directly to the database. You can keep them out, and you can just put ORDS in the mid-tier and give them access to SQL Dev Web in the browser, and they'll never directly log into the database. They'll always be going through this, and especially if it's just for running SQL statements, then you don't have to worry about maintaining TNS files and SSH tunnels and all of that, and Java homes and Oracle homes and all that good stuff. All right, Alfredo, hey man, thanks again. I think this is an awesome idea. I think there's like what, 17 or 16 weeks left of this, so everyone make sure you come back at the same time next Wednesday.
Absolutely. Yeah. 17 more weeks to go. I really appreciate you taking the time and speaking to our user group. I know I first asked you to do something like this back in 2016 at GLOC, and we've been trying since to kind of sync up, and I'm really happy that it finally happened. Because you've got
nothing like the world catching on fire to
to make it happen.
Up to make it happen.
Yeah. So
well, I look forward to coming to Chicago in person and saying hi to everyone.
Yeah, that would be great. Yeah, I really appreciate it. Thank you. And for everyone else that's on the call, like I said, next week we'll have Oracle A Sean Scott on getting started with Oracle and Docker. So you can register for that now. And we'll see you same bat time, same bat channel next week. Have a good day, everyone.
Cheers.
Cheers.